Hi guys, welcome back to another video. Today we are diving into something super useful, configuring MikroTik Cloud Dynamic DNS service and exploring two real-world use cases. If you ever struggled with the dynamic IPs from ISPs and you got a MikroTik router, this one is for you. One of the biggest challenges with the consumer internet plan is that they don't come up with static IP by default. Even if you go for a static IP, it gets expensive. Although in India, we get static IP for cheap, but that's not the case with other countries such as US, UK and Canada and so on. Although the dynamic IP would work just fine for everyday browsing and outbound traffic, but things get tricky when you need remote access, whether it's port forwarding, IPsec VPN, SSL VPN or hosting a service. Until one day, the IP changes and boom, you lose access. Don't worry, we are going to solve that problem in this video using the MikroTik built-in DynDNS. There are plenty of third-party providers like Oracle DynDNS where you can register, pay for a subscription and get FQDN that automatically updates whenever your IP changes. This keeps your remote access uninterrupted. But here's the catch. Most of the services require a paid subscription. I'll cover the third-party DynDNS setups in a separate video, but today we'll focus on the MikroTik built-in solution, which is free. By the end of this video, you will know exactly how to enable MikroTik Cloud DynDNS and set it up step by step, which is just one click anyways. I also have a detailed guide on my blog article with the step-by-step guide, so make sure to check that out. For this demo, I'm using two physical MikroTik routers, one at home with the dynamic IP and another at the remote site with a static IP. Since my remote site has a static IP, I don't need a DynDNS there. But at home, that's where we'll set up MikroTik Cloud DynDNS and make sure everything stays accessible even when the IP changes. Alright, let's get started. Before that, if you like what you're watching, please ensure to like the video and subscribe to my channel. So first let me go to my home router and check the IP. IP addresses. I have a public IP ends with 126 and I also have an IPsec tunnel running between these sites. So I go to IP, IPsec and active peers. You can see the IPsec tunnel is established and everything looks good. And in case if you're wondering how you can set up an IPsec VPN on MikroTik router, you can click on the link at the top right corner. I'll also put the link in the description as well. The problem, however, anytime when I reboot, the public IP changes and the tunnel and whatever the services I enabled from public internet would then go down. To enable the service backup again, I have to now go back to the remote site and then manually change it. Sometimes if you don't have anyone at the remote site and there's no other backdoor to the remote router, you're basically stuck. So luckily, I have set up a backdoor through OpenVPN in AWS. That AWS OpenVPN public IP I have whitelisted in my MikroTik remote router. Even if I lose access, IPsec tunnel goes down, or my IP changes, I just have to enable the OpenVPN and then I can get back into my remote router and make the changes. Let's go to terminal and try to ping my default gateway 192.168.1.254. Okay, it's pinging. The Winbox dark theme that you see is my remote branch, which I can access it now as I have whitelisted my home router public IP. But when I reboot, the home router IP would change and I lose access. You can see the IPsec tunnel is running here as well. Let me go back to my home router. As you can see, I have an IP address that ends with 126 and let me go to system and then click on reboot. And I lost access to my router. And the ping is now timing out. It will take a minute or two for the router to come back up. Waiting. Alright, finally the router is back up. I lost access to my remote branch router, which I was accessing before using my public IP ends with 126. So it must have changed now, so I can't access anymore. And if I log into my home router, as you can see, I got totally different IP, which ends with 36 at the end. And my IPsec tunnel is also gone down, and I don't see anything under active peers. To access my remote site back again, let me connect to my backdoor, which is OpenVPN. Let me open OpenVPN and click on connect. It's connected now. Let me cancel it and try again. Try now, authenticating, and I can access the remote branch now. Great. If I go back to my IPsec peer configuration, you can see my home public IP ends with 126. I manually configured here. Other than the AWS IP, I had the same 126 IP whitelisted as well in the firewall rules, which is now changed. As a result, when I rebooted the home router, I lost access to remote branch. Now you understand the pain of dealing with dynamic IPs. So let's go ahead and fix that. To enable the DynDNS in MikroTik, go to IP, Cloud, and check the DDNS enabled option and click on OK. Get back into the same window again, and you can see now DynDNS is updated. Let me copy the FQDN. Sometimes the DynDNS or Cloud wouldn't update the IP. It will stuck at updating. So if you ever stuck here and DynDNS is not getting updated, you may go to firewall rules and then configure the output rule as shown here. So it is important for the DynDNS to work. If I now go back to my IPsec configuration, you can see still the IPsec tunnel is down. Let me go to peer configuration and update the address to the DynDNS FQDN. Paste that here and click on OK and go to active peers again. Message once sent, and now it is established. Let me disconnect the OpenVPN. Disconnect, and after a few seconds the connection will be lost. In the meantime, I go to IP address. I cannot see anything because the traffic is coming from different IP now. It's getting dropped by the remote router. And as you can see, we lost access to the router now. Let me connect back to my VPN, connect, and click on try now. Let me now update my FQDN as trusted source in the remote router. Go to IP, firewall rules, click on address list. Let me change the IP address to the DynDNS FQDN. Click on home IP, give some friendly name. I'm adding DynDNS at the end. And paste the FQDN and click on OK. And there is a dynamic address entry added as well, which frequently check what is IP address mapped to this FQDN. Now let me go back to my input filter rules and change the source address list to the newly created address list with the FQDN and click on OK. If I disconnect the OpenVPN, I will lose access for a second because the TCP should now reinitiate and establish on the new IP, as access to the router would switch to my home public IP from the AWS IP. Because the IP is whitelisted at the remote branch, I still be able to access the remote site. It's not disconnected yet and the IPsec still shows fine. Let me ensure I have disconnected the VPN. Yes, it is. I could also set up a DynDNS where I have static IP, which is not needed, but you can still do. Like we did in a home router, check the DynDNS option here and click on OK. Alright, it's not updating, which means we are not able to talk to the router. As I said before, I lost access to the router now and I'm not going to reconnect the VPN. Instead, I'll just simply click on try now. And it worked. I can now access the remote branch using the whitelisted DynDNS FQDN. And let me now enable the DynDNS, which was not checked because it did not have connectivity, and click on apply. I got new DynDNS FQDN. So that's it in this video. If you have any questions, please let me know in the comment section below, and I'll see you guys on the next one.